All right, today we are diving deep into a piece of technology that is absolutely changing the game for marine propulsion. We're going to break down the Caterpillar MaK M 46DF, a seriously powerful dual-fuel engine that's helping steer the whole shipping industry toward a cleaner, more sustainable future.
So, to really get a handle on this engine, you first have to understand the world it lives in. Our story starts right here, on the vast open ocean where the arteries of global commerce are constantly flowing. Get this, a staggering 90% of everything we trade around the globe travels by ship. It's the invisible engine of our economy. But that crucial role has a pretty hefty environmental price tag. And that's a challenge the entire maritime industry is now being forced to tackle head-on. Okay, so here's our roadmap. First, we'll look at the regulations that are forcing this massive change. Then, we'll meet Caterpillar's answer. We'll pop the hood and see what makes it tick, cover the really critical safety stuff, and then finally, we'll get into the real-world environmental impact. So first up, we've got to understand the why behind all of this. We're talking about a huge regulatory push that's kicked off nothing short of a technological revolution at sea. For any engineer in this field, this is the essential background you have to know. So, the International Maritime Organization, the IMO, has been rolling out tougher and tougher rules. Tier 1 was just the beginning. Tier 2 really tightened the screws on pollutants like nitrogen oxides. And then came Tier 3, which demanded this huge reduction. This timeline, right here, is the exact reason engines like the M46DF even exist. Okay, so how in the world do you meet these incredibly strict standards, but without giving up the raw power and rock-solid reliability that these massive ships need? Well, let's meet the solution, the dual-fuel powerhouse. And here it is, the Cat MaK M46DF. Now, this isn't just an engine. It's an engineered solution built for one thing above all else, flexibility. It lets a ship switch fuels on the fly so it can comply with the strictest rules in protected zones and still operate efficiently everywhere else. For operators, that kind of versatility is absolutely everything. Okay, this slide shows off one of the engine's most brilliant design features. See how the new M46DF and its older sibling, the M43C, have the exact same footprint? Now, why is that such a huge deal? It means shipyards can literally pull out the old diesel engine and drop this new dual-fueled beast in its place without massive structural surgery. That's exactly what they did on the tanker Fury West. Now, let's just peek at the numbers. I mean, this is a serious piece of machinery, kicking out almost 8,700 kilowatts. But the most important thing to see here is its dual compliance. When it's running on gas, it meets the super strict IMO 3 standards. Switch it over to diesel, and it still clears IMO 2. That, right there, is the definition of operational flexibility. All right, time to go under the hood. We're going to take a look at the core systems, both mechanical and digital, that make this engine run. For any engineer or operator, knowing these components inside and out is totally non-negotiable. A really key design philosophy here is modularity, so each cylinder head is its own self-contained unit. This is a massive win for maintenance crews because it makes service access way faster and easier. And in the shipping world, less downtime equals lower costs. It's that simple. Now this is the secret sauce to its dual-fuel power. In gas mode, the engine is mostly burning natural gas. But to get it to ignite, the system uses what's called a micropilot injection, just a tiny, super precise spray of diesel that acts like a spark plug. It's an amazingly reliable system that gives you clean, consistent power. And the thing managing this whole orchestra is the engine's digital brain, this SaCoSone control system. It's completely automated, constantly checking things like cylinder pressure and exhaust temps to keep everything running at peak efficiency. The really cool part? It can switch from gas to diesel and back again without any interruption to the ship's power. It also has its own independent safety system, which adds a really crucial layer of protection. So you have this incredibly advanced piece of engineering. Well, that demands an equally advanced approach to safety. The technology is amazing, but, it's only as safe as the skilled professionals who are actually running it. The technical manuals couldn't be clearer on this. Operation and maintenance have to be done exclusively by qualified personnel. And it all starts with the basics, the right personal protective equipment. In a noisy environment with blazing hot surfaces and high-pressure systems, things like safety shoes, ear protection, and safety glasses, they aren't just suggestions. They're the absolute minimum requirement. An engine room is just an inherently hazardous place. The manuals are loaded with warnings that crews need to know by heart. Hot gases can instantly ignite spilled oil.
Some engine surfaces can give you a severe burn in a split second, and those high-pressure fuel systems can be lethal if you don't handle them right. Any hot work, like welding, requires a strict permit. When it comes to safety, there are absolutely no shortcuts.
Okay, let's circle all the way back to where we started, emissions. We know this engine is a huge part of the solution, but it's really important to look at the whole environmental picture, warts and all. So switching to natural gas gives you massive wins. It pretty much eliminates sulfur oxides and slashes nitrogen oxides. But it's not a silver bullet. It introduces a totally different kind of environmental challenge that we have to talk about.
And that challenge is called methane slip. This is a super important term for any dual fuel operator. Basically, it's the tiny bit of unburned methane fuel that manages to slip through the engine without being burned and then gets released in the exhaust.
Now, methane is a really potent greenhouse gas, so this is definitely a concern. But, and this is a big but, the technology has gotten so much better. Studies on modern engines show that methane slip is way down compared to older models. And as you can see from this chart, it really depends on the engine load. It's much, much lower at the high loads where these big ships spend most of their time. But the innovation didn't stop with just making the engine better. The next evolution is already here. Methane abatement catalysts, or MACs. You can think of it like a super sophisticated catalytic converter, but for methane in the exhaust. And the potential here is just wow. A recent study of one of these new MAC systems showed it had a methane conversion efficiency of over 95%. That means this tech can basically grab and neutralize almost all of the remaining methane slip. It just takes clean to a whole new level. So when you take engines like the M46DF and then you pair them with after-treatment tech like MACs, you're looking at a massive leap forward. It's a complex fix for a complex problem, for sure, but it really makes you wonder, with this kind of innovation happening, are we on the edge of a truly sustainable new era for shipping?